Now we want to put all those pieces together on how we graph a polynomial function. So we're going to look at zeros, we're going to look at multiplicity, and we are going to graph. So the first thing I want to do here is I want to give you a little bit of a definition for multiplicity. Multiplicity is the number of times you get a zero value when you solve. So here, multiplicity is going to be the number of times you get a zero value. Or it could be the number of times you get an x-intercept, or the number of times you get a factor, because remember all those things are tied together. And we want to count the number of times we get a zero. And when it comes to graphing, if we have an even multiplicity, the graph is going to bounce at the x-axis. Graph is going to bounce at the x-axis. So whatever way we come from, it's going to head back in that direction. If we have an odd multiplicity, it's going to go through the x-axis. So we want to graph this polynomial function by hand, list the multiplicity of each value as you find it, and after you have a graph by hand, find the relative extrema using a graphing calculator. So here, f of x is equal to 5x to the fourth minus 11x cubed plus 6x squared. First thing we want to do is we want to find all the zeros. Once we know the zeros, we can talk about multiplicities and what the graph is going to look like based off of end behavior. So we've got f of x is equal to 5x to the fourth minus 11x cubed plus 6x squared. And let's find our zeros. We can start by factoring out an x squared. So 5x squared minus 11x plus 6. Once I do that, I can factor 5x squared minus 11x plus 6. And in order to do that, I say 5 times 6 is 30. What are the factors of 30 that add up to negative 11? And it's negative 5 and negative 6. So 5x squared minus 5x minus 6x plus 6. And now I can do my factor by grouping inside these parentheses. Still have this x squared on the outside. From the first group, I can factor out a 5x, and I'm left with an x minus 1. On the back side, I can factor out a negative 6, and I'm left with an x minus 1. So then when I simplify x squared, I would have 5x minus 6, and then x minus 1. So there are my factors, and then the way I convert these factors to zeros is I set each piece equal to 0. So I say x squared equals 0, 5x minus 6 equals 0, x minus 1 equals 0. So then my zeros end up being 0, 6/5, and positive 1. So I found my zeros. Step 2. Let's talk about multiplicities. How many times does each zero occur? So I'm looking at 0, 6/5, and 1. 0 occurs 2 times. And the reason for that is that this was an x squared. So there are 2 values that make up 0. And if you want to think about it in terms of plus and minus 0, in essence they're the same thing, but there's 2 mathematical ways you can look at coming up with 0, even though plus and minus 0 really doesn't exist. But there's 2 answers with a squared term. The 6/5 occurs 1 time, and the 1 occurs 1 time. So if we look at that in terms of how the multiplicity plays into our graph, when we've got an even multiplicity, it bounces. An odd one, it crosses or goes through the x-axis. And that one's 1, so it crosses or goes through the x-axis. Step 3 is we're going to graph. And we can start by filling in the pieces we know. I know my zeros are 0, 6/5, and 1. And 0, 6/5, and 1 are my zeros, which are also my x-intercepts. So I'm going to put those on the x-intercept, or the x-axis. So there's 0, there's 1, and then 6/5 is 1 1/5, so it's slightly past 1. Now we know our end behavior as well. Right here, 5x to the 4th, that's a leading coefficient that is positive and even. Positive and even means that in the end, both sides are going to be up and up. Now we can start drawing our graph, looking at it in terms of bouncing and crossing. So when I come down to the 0, okay, I've reached the 0, is my graph going to go beneath the x-axis or is it going to go back up? Well, it's going to bounce back up, and then it has to come to the next 0. So somehow, and I'm not quite sure how high, but it's going to do something like that. It's going to bounce, but then the graph, since this is a polynomial function, is continuous, which means I have to come back down in a curved shape. This right here is my x-intercept of 1, and we know it's going to cross the x-intercept there. It's got to come back and hit that x-intercept. This one is the 6/5, which means it's going to go through that since that one has a multiplicity of 1. So my graph is going to look something like that. I don't know how steep it is, and I don't know how much of a hump I've got here. But that's the last piece for us to do, is we want to find the relative extrema using a graphing calculator. And relative extrema are just saying the maximums and minimums that occur between those zeros. So to do that, we'll pull out our graphing calculator, and we'll type in our function. 5x to the 4th minus 11x cubed plus 6x squared. And as I look at that, I really don't see too much right there. Sort of looks like just a parabola. So we'll zoom in a little bit. Let's take a zoom box. And we know I'm really interested in the piece that's a little bit after 0 and the piece that's between 6/5. So what I'm going to do is I'm just going to draw a box a little bit after 0 and before the 6/5. There we go. Here are my two relative extrema that I'm trying to find. And you can see with this x to the 4th function, they are so close to that x-axis. Now the way we find our relative extrema is we go to our second trace, which is our calculations. And we're going to choose minimum and maximum. I'm going to choose maximum first because I want to know what the height of this piece is. So we'll choose a left bound, something to the left of the maximum. We'll choose a right bound, something to the right of the maximum. And then our guess is somewhere in between. So there's our relative maximum, 0.541 and 0.442. So here's my relative max, and my relative max is going to be 0.541, 0.443 when we round it. And then we're going to do the same thing again now, finding the relative minimum right there. So go second calc, but this time we're going to choose minimum, and we'll scoot our way over. Right before the minimum, something to the left, hit enter. Choose a right bound, something to the right, hit enter. And then guess is where we think the minimum is. And there's our relative minimum at 1.109 if we round to 3 decimal places, and then negative 0.061 when we round to 3 decimal places. So right there's my relative min. and it's 1.109 and negative 0.061 rounded to 3 decimal places.